Hello, I am Ishan Bhatt from MDX Tutors, and today we are going to have a brief understanding of a very important aspect of understanding physics in a detailed manner. And the topic we are going to study today are waves. Now, try to change the font. Waves. Now, understanding waves is very important because in physics usually see that we have basically two types of objects in understanding energies. And energy understanding energy of an object or any particle, we usually deal with two types of forms of those energy. One is a small particle and the other being a wave. Now, these particles and waves are somewhat in classical physics. When we try to understand physics in terms of what Newton told us, these two are different. But when things go down to a very small level, things become very much absurd, and that will be later dealt in detail in later classes. Now, these two forms of energies that we have, one is a particle and the other is a wave. Understanding these waves are very important because what are the types of waves? What waves do we deal with in physics? What are the different components of a wave? Different equations that we understand using waves? How do we measure the speed, the velocity of these waves? What are the different types of interactions and their physics, like reflection and transmission, then absorption, then refraction? All of these things need to be understood in detail. Let us just go to a brief understanding of how does a wave actually look like. Now, a wave is can be, I try to draw a little bit irregular wave so that things become uh, easier to understand. Now let us just consider only this fragment of the wave, only this much. Now if we consider only this fragment of this wave, then we understand that there are various components of this wave. Now the mean equilibrium point from which we see these vibrations, waves are nothing but different vibrations, and those are forms of energies. Now these, from this equilibrium line, we say that a wave which is traveling for this particular time period of interval, the amount of number of oscillations it has done, that number of oscillations is said to be the frequency. So number of oscillations is frequency, and the SI unit of frequency that we use is hertz, which is nothing but inverse of a second, 1 over second. The other component of the wave which we understand is the inverse of these number of oscillations. That is how much time has passed for this time interval. And the time interval that we have taken, that will give us the time period of that particular oscillation. And that is given in the SI unit of seconds. Another important component that we come across in field of waves is wavelength. Wavelength is nothing but the amount of distance between two same points on two different consecutive waves. So for example, we have a wave packet over here, and if we consider this particular peak of the first oscillation, and of the just the consecutive next oscillation we consider the same peak, these two are having almost, actually they are having the same amplitude, and the amount of distance which is in between them, this particular distance, this distance gives us the wavelength. This will give us the wavelength, and this wavelength is denoted by various uh, notations. The most common which is used is the Greek letter lambda, which somehow I cannot draw it over here, but it is given by this Greek letter lambda. And lambda is nothing but the wavelength, wavelength of this uh, oscillation. Then this frequency, which are the number of these oscillations, is given by the denoted by the letter nu. So a very important equation which comes in when we deal with this waves is that the speed of a wave is given by multiplication of its wavelength times the frequency. So if you are given the frequency and if you are given the wavelength, then you get the speed. Now let us just cross check. We know that this speed has its unit as meters per second. So this wavelength is of the units meters, wavelength of unit meter, and frequency of 1 over second. So when you multiply meters with 1 over second, you get the speed meters per second. So these are the different types of uh, components of a wave. Another component which I would like to share is amplitude of the wave. Amplitude is nothing but how much maximum the maximum point of a wave oscillation, how much it has deviated from its original equilibrium position. So this much is given the amplitude. So this is the amplitude of this particular oscillation, amplitude given by the letter A. Now this amplitude A is also some form of distance. So it will also have the SI unit as meters. And you can see that this oscillation is even bigger. So this oscillation has its amplitude even bigger. So if you have, let's say if we try to give several examples for particular wave packets, if we are having this much waves and having the same time period, roughly the same time period, and only this one particular oscillation. So what do you think? Which will have more number of frequency? Answer is actually this one. This will have more number of oscillations for the same time period. So the frequency will be higher. Which of these two will have higher wavelength? The second one will have higher wavelength, because you can see that if you take a point here and the next wave which is going to be like this will, for this particular time period and the equilibrium like this, so this will be the next wave. So the amount of distance it has to travel is from here to here, right? But For this particular wave, the amount of distance is from here to here. So the distance is less. Now you can understand this that for a fixed speed, for two waves having fixed speed, if your wavelength increases, then your frequency has to decrease so that the multiplication remains constant. If your wavelength is less, then it is bound that the frequency of that particular wave will be higher. As you can see in this example, the frequency was higher in the first one, so it was lower in the second one. But the wavelength was smaller in the first one and higher in the second one. If we are considering both having the same speed, then this relation is 100% true all the time. Now, let us take one more example. Another example which I would like to take is two waves. One is having this, one is having this. See, the number of oscillations for both of these waves is same. So the wavelength is same, the frequency is same, the speed is same. But one thing which is not same is the amplitude. If you see, the highest point from here, from the equilibrium position, is only this much higher. But for the second one, it is even higher. So the amplitude of these two are different. So this is about the different components of a wave. Now, we'll try to understand more about what are the different types of waves. Now, there are two different types of waves which are very important to understand. Types of waves. The first type being the longitudinal waves, and the second one being the transverse waves. It's very easy to understand both of them, and I will also give examples so that it becomes clearer. Now, let's say we have different particles, right? We have different particles here, and a wave is being traveled from one end to other end. So these particles, what is happening is, if let's say you have a rod, a huge rod, a long rod rather, there are all these particles which are fixed on this rod. So when you strike one end of this rod, the particular atoms which are here, it will transfer its energy to the next atom which is here by going towards it. Then it will strike it and then go again back. Then this energy will be transferred from this particle to the next particle. And so on and so forth. These energies will be traveled in this direction, and the wave will reach from here to here. So in all of these, in this example, you will see that the motion of this particle, motion of all the particles are in the same direction as that of the transmission of the wave. So when motion of the particles is in the same direction as that of the wave, then that is an example of longitudinal wave. Example of longitudinal waves are sound waves. Now, if you strike a rod with a heavy metal, then you will see that that rod will be struck and the particles will travel from one end of the rod to the other end, and all of these particles will move in the same direction as that of the wave. However, in the case of transverse waves, you will see that it's rather difficult to understand that with the help of a diagram, but still I will try to explain you that when you have a light wave, an example of transverse wave is a light wave. A light wave when travels like this, so it has two different components of electric field and magnetic field. When the direction of motion is that of in the same direction, when the direction of motion is in the x direction, you will see that the peaks and troughs, they are having the same direction as that of the motion of the wave, but the vibrations are actually at right angles to the direction of the wave. Vibrations are perpendicular to the direction of the wave. So these are the two types of waves. In transverse waves, in example being light or any other electromagnetic wave. Different types of electromagnetic waves are microwaves, radio waves, visible light, ultraviolet light, infrared light, X-rays. All these rays are different types of electromagnetic rays. And the longitudinal waves are like sound waves. So transverse waves, you basically have the crests, peaks and troughs, and in longitudinal waves you have compressions and rarefactions. So one last thing which I would like to tell you is that what are the different types of electromagnetic waves. Now, if we draw an electromagnetic spectrum, drawing uh, types of types of electromagnetic waves, when we draw an electromagnetic spectrum, right, and when the waves are, when the wavelength is very huge, coming down to very smaller wavelengths, excuse me for the, oops, sorry. Oh, second, sorry for that. Amplitude is actually the same. So, but you get the idea that even though the amplitude will be same, the wavelength will keep on decreasing. What are the different types of these electromagnetic waves? We have the largest wavelength being that of radio waves. For case of radio waves, the wavelength is the order of 1000 meters. So they are very, very huge. Then from radio waves, we go on to microwaves, which is roughly 100. Then we go on to infrared, which is roughly around 10 to the minus, microwave is, sorry, 10 to the minus 2 meters, and infrared is 10 to the minus 5 meters. Then we have visible light, which constitutes of all the 7 colors, the 10 minus 6 meters. Then we have the UV, or the ultraviolet light. It's very easy to understand how these UV comes later or infrared comes later. Why? Because in visible light, we have Vibgyor. So rather is actually like this, Vibgyor. That is because red is having more, red is having more wavelength, and V is having lesser wavelength. So you can see that when Vibgyor is here, which is the visible light, then what comes after violet is ultraviolet. So you get ultraviolet, and what comes before R, which is red, is infrared. That means smaller than red. So what is smaller than red? It's not, wavelength is larger than red of infrared, but the frequency is small. So here the names are given according to the frequency. So then after ultraviolet, we have X-rays, which are pretty small wavelength, wavelength of almost 10 to the minus 10 meters. And then you have extremely high intensity waves, which are called gamma rays. So, which is as small as 10 to the minus 12 of meters. So these are the different types of electromagnetic waves depending on their wavelength and frequency. So these, for these waves, the frequency wavelength keeps on decreasing in this fashion. So the frequency, which is the uh, denoted by the letter mu, frequency keeps on increasing in this direction, but however wavelength keeps on increasing in this direction, wavelength given by lambda. So these are the different types of electromagnetic waves. I hope you learned something new from this session, and we'll try to make one more video giving more insights into the different types of electromagnetic radiation in the atoms, then sound waves, and some things about interactions like reflection, transmission, absorption of an electromagnetic wave on a surface. So that things will also be covered. Thank you for this. Please stay updated. Thank you so much.